Okay, so today we'll be learning like how to use Lensmaker formula. So first I'll discuss what is Lensmaker formula with an example. Then we'll solve some numerical, and then you have to proceed towards a quiz where you have to solve some questions related to Lensmaker formula. So what is basically Lensmaker formula? So suppose I have a lens like this. Suppose there's a lens on one side. Suppose radius of curvature is r1. On another side, suppose radius of curvature is R2. And please remember, Lensmaker formula is applicable for thin lens. Thin lens means these two sides are very close to each other. Suppose the refractive index inside is N2 and outside is N1. Then the focal length of this lens will be given by 1 upon f equal to N2 upon N1 minus 1 upon R1 minus 1 upon R2. But please remember, you can use this formula only when the refractive index on both the side of the lens is same, like N1 and N1, and inside it is N2. And also remember the sign convention for radius of curvature. So if curvature is like this, then R should be taken as positive. If curvature is like this, then R should be taken as negative. And if curvature is like this, then R will be taken to be equal to infinity. So let's take one example. Then we'll proceed to some kind of lens. Suppose that I ask you, what will be the radius? What will be the focal length for this lens? Suppose I have a lens like this. And on this side, the R will be infinity. Suppose on this side, the R is 20 centimeter. Suppose the refractive index inside is 2 and outside is 1. So what will be the focal length? So 1 upon F will be equal to N2 upon N1 minus 1 upon R1 minus 1 upon R2. So if I put all the values, then N2 is 2, N1 is 1, minus 1 upon R1. R1 is infinity, minus 1 upon R2, and R2 will be plus 20. What is the reason of plus 20? Because the curvature is like this, so R2 will be plus 20. So if we'll solve this, then 2 minus 1 will be 1, and 1 it will be minus 1 upon 20. So 1 upon F will be equal to minus 1 by 20. So focal length is basically minus 20 centimeter. So this is a diverging lens. So this is how you have to find out focal length of any lens. Okay, suppose there are few kind of lens, like this is double convex lens. So if this is R1, this is R2. So if we put the values, then R1 you will take positive and R2 you will take negative. For plano convex, infinity, and suppose in the on this side R2, and it will be negative. Converging meniscus, both will be negative. Double concave, this will be negative, this will be positive. Plano concave, for here infinity, for this positive. Diverging meniscus, this also positive and this also positive. So this is how you have to put sign convention. Let's take one more example. Suppose I ask you, what will be the focal length of this lens? Suppose the inside refractive index is 3, outside refractive index suppose is 4. And suppose the radius of curvature of this side is 20 centimeter and radius of curvature of this side is 30 centimeter. So how will you find the focal length? So 1 upon F will be equal to N2 upon N1 minus 1 upon R1 minus 1 upon R2. So if we'll put the values, then N2 is the inner refractive index, that is 3. N1 is the outer, that is 4, minus 1 upon R1. Remember, the R1 is this one, and the curvature is like this. So it will be plus 20, minus 1 upon R2. R2 will be minus 30. So this is how you have to put all the values. So 3 by 4 minus 1 will be minus 1 by 4, and 1 upon 20 plus 1 upon 30. So you have to solve this and you have to get the focal length. So this is how you have to calculate focal length of different kind of lens. Now, if we have focal length, then we can directly use the lens formula. So lens formula is 1 upon V minus 1 upon U equal to 1 upon F. And the magnification due to lens is basically V by U. And magnification is also equal to height of image upon height of object. So if you know how to calculate focal length, and if you have U, then you can easily calculate V. Suppose I ask you that I have a lens like this, and the curvature of this side is infinity. It's visible. On this side, 20 centimeter. Inside refractive index 2, outside is 1. And suppose I ask you that there is an object at 50 centimeter from lens. So where will be the image be? So focal length you already know how to calculate. You will be taken as minus 50. Remember, light is going in this direction. So anything measured on the backward side will be negative. On the side of light will be positive. So you will be minus 50. You can easily calculate V. So this is how you can calculate object location, image location when you know you have a lens of any kind. But if radius of curvature is given, refractive index is given, you can calculate F. And if you have U, then you can easily calculate V. This is how you have to use lens maker formula. Okay.